Okay, so I think in this exercise, what we are going to do is to classify the different cell lines into different subtypes. Okay, so we need two sets of data here. One is the ICGC data for the pancreatic cancer, which you have already identified all the subclass, the subtype. Another data would be the gene expression profiling data from the CCLE. All right, so now I'm just going to import in the data that we have previously. So, okay, so this is the, let's see, where is this? Where is the, I think this is the data that we have. Oh, not this one, sorry. Yeah, this. Okay, so this is the data set that we have downloaded previously. Okay, and already calculated the Z-score. Remember that? Okay, so this is the one. So look familiar, right? Okay. Now, so the next data set that we need to download is actually the CCLE data. You can just go to CCLE broad, then you can download it. So if we go to the CCLE. Okay, then you can go to the data info here. Okay, that will land you to the CCLE homepage at the Broad Institute. So you need to log in, I mean, sign in order to download the dataset. So, okay, you sign in here, then you go into here, the dataset. You can browse the data. Now, so in the CCLE dataset, you have about 56.2 gig of data here, include DNA copy number, mRNA expression, and some of it include the pharmacological profiling as well. So for this exercise, we will be mainly interested in the mRNA expression. Okay, so there are multiple versions of the mRNA expression, and all this was done by using the Affymetrix microarray. So this part 1, 2, 3, and 4, the CEL files, these are the raw data. So we won't be using it. So instead, what we will be using for our exercise is actually, let's see, this will be copy number variations. Oh, sorry, this is copy number. I want to look at mRNA, should be here. Okay, so now what we need is, let's see, basically this one. This is, oh no, this is a sample info. Oh, here. So gene-centric normalized data set. Okay, so you can download this one. You just click it and then it will download into your computer. Now, uh, it's a .gct format basically, but you can open it with Excel easily as a text file or in a notepad or anywhere. So now to save the time, so while waiting for it to download, I'm going to show you the downloaded dataset. So, and I'm going to open this in the Excel. So just going to browse. So let's see that where did I download the file? Oh, that is in my another hard drive anyway. So is it here? It will take a while for it to run. Okay, so this will be what you will be seeing when you open the file like this. So you have here, uh, this is the name of the cell lines. Okay, so they are all together, I think, close to 1,000 cell lines, but of course we only focus on the pancreatic cancer, basically. So, so how are we going? And of course, then you have a gene name here on this side. So you can disregard the proof set number at this point. So what you're going to do is that basically you can copy this. These are all the cell lines name. So you see the format that they have is that, well, the first name denote the cell line names followed by the tissue site. Okay, so I'm going to basically separate the cell name from the tissue site. So I'm just going to go to data and then text to column. So this will be underscore. So now then you will have cell names in one column and then of course the tissue site. Okay, so that's how you get it. Now, so okay, now you have all the cell names here. What I'm going to do is I'm going to copy and paste it over here. Now this row only have the cell names. Then I'm going to insert one more row here, which will have the information about the tissue site. Okay. Oops. Here. Okay. So now, remember we only want the pancreatic cancer, so we are going to sort it based on the tissue site first. Sort option left to right, and this will be row 1, A to C. Okay. Oh, selected the wrong area, so I should just select this area only. So again, left to right, row 1. Okay, so now it is sorted, so this is okay. So we do need the autonomic, biliary, bone, and all this data. So we can all delete all this part, and we only focus on the pancreatic. Okay, so we can delete all this part here. Now you have your pancreatic here, pancreas, okay, pancreas. This one also no need. Okay, so now uh, So now you have your CCLE data set here. Okay. So the next thing is that I'm going to copy your what you call it, the C-score data set. That, oh, before that, I think I need to calculate the C-score. Okay, so I'm going to calculate the mean. So this is still on the CCLE data set. So how to calculate the C-score again is equals to this value minus mean, right, divided by the SD, correct? Okay. So so now you have all the C-score here. Oh wait, this is always, so forgot to put that in here. Okay, so this is all your C-score, right? Okay, good. So I'm just going to convert this into text instead of formula. Okay, I can delete the raw data here. So these are all your C-score. Okay, so I do need the probe set also. I can delete this. Okay, now then the next thing is that I'm going to import in your ISGC dataset, the C-score that you have already calculated. So here you go. This is it IGS? ICGC. Okay, so this is your CCLE dataset. So now you have two datasets here, basically, with the C-score. Now, uh, one thing is that if you look at the number of genes here for the ICGC, you have about 16,000 genes. For the CCLE, you only have about, like, no, should be more than that. About like 18,000. So over gene as well. So it doesn't match. Basically, the two data set, it doesn't match. So the next step what we are going to do is we need to harmonize the two data set. Okay, so that the common uh, the common unit for integration would be the gene names. Okay, so to do that, I need to clean up a little bit here on the CCLE dataset because some of the probe set from the microarray it doesn't target any gene, so I'm going to uh, remove those. Okay, so these are the entry that have the probe set, but they don't have a known target. Some of this could be the positive control and negative control and so forth. I'm going to remove this. All right. Okay, so how are we going to harmonize it? Okay, so I'm going to determine whether these genes appear in the CCLE are also appear in the ICGC set. So what I'm going to do is I'm going to use a formula, count if, okay, the range, count if this range here match with this entry. So straight away you see here this one do not have. So to counter check whether you can find this name over on this data set or not. So you will see that it shouldn't find anything. Okay, so that's one way you can counter check it. So you can just copy it all the way down here. So it's still calculating. Okay, so some of it have the same gene names in the ICGC, just to cross check again, see whether you can find it. Okay, so we can find that, so that's great. So now what I'm going to do now is I'm going to delete those that are okay. So in the microarray, sometimes you can have more than one probe set to target the same gene. So now, when you want to do the classification later on, so it is important that you only have one unique identifier. So if you have more than two entry with the same genes, then the algorithm would not be able to reconcile which one is which. They cannot treat it two entry as the same. Okay, so what I'm going to do is I'm going to remove those genes in the CCLE that do not match with the ICGC, and also those that have more than one match with the ICGC. Okay, I'm going to remove this. So, okay, it will take a while. So when you do your previous analysis, how many of you have the computer hang and everything not running?
Not really. We are using the collab one.
Oh, okay. Mm-hmm. Which one? The computer lab upstairs.
Library.
Oh, okay. Okay, it's done. So now what is left is basically these are the genes that appear also on the ICGC. So now you do the same for the ICGC to match the genes. Count if. So uh, whatever appear here should appear here as well. Okay. Oops. Ouch. Okay. So then you will see that, okay, some of the genes, these are the genes that appear on this dataset but not in the other. So again, counter check it, see whether you can really find it. Nope, you can't find it there. And it's a bit slow. You recalculate. So and see whether you can find this over this side. Okay, that's good. Okay, now I'm going to delete again all those that doesn't match with the CCLE dataset. Okay, we'll try again to remove this. Hopefully it won't hang this time. if it's still, well, if you experience this hanging, what you can do is that you can first sort it out first, so then you can, sort out here with the 1 and 0. Then after that, you remove it. Instead of removing all at the same time, you can remove a few row at a time. Yeah, because at the moment I'm using the filter, so then the computer actually have to go through each row to actually remove the one that I wanted. So it have to skip and some maintain, some skip, some maintain. So that's why it take a longer time for that. So if, well, depends on your computational power. So most of the time, filtering and deleting is the most expensive one in terms of, when it comes to the analysis. Well, see whether it will work this round. So basically what we are trying to do here, this is just the harmonization step. Okay, so to make sure that the two data sets basically match with each other. Okay. Okay, so now you should have two data sets that match with each other just to see, just to check. So you have about 13,13091 entry here. So this should have the same number. Okay, 13092. Basically, just going to compare these two. I mean, if it's matched perfectly, then the number of genes in two data sets should now be equal, right? Oh, they have another two more here. Why is there some extra? There's something wrong, so let's double check it again. Now if this one over this one. Oh, there's still some here that I did. Oh, okay, I didn't delete this. Okay, now that should work. Okay, let's compare that again. Okay, versus this. So they should have the same number. So now they're equal now. Okay, that's good. But of course they still doesn't match with each other. Okay, so now, so what I'm going to do now is basically try to match them together. You can use the VLOOKUP if you want to, but then that will take up a lot of the computing power. Instead, I'm just going to do a simple sort and then double check whether it match or not. So I'm going to insert one column here. I'm just going to sort it by alphabetical order. Okay. Okay, so it's by alphabetical. The other one, CCLE, I'm also going to sort it by alphabetical order. Okay, so now I'm going to just to check whether they match with each other. So now again, so if you can use the formula if this value is equals to this, and then it will return as 1. If not, then it will return as 0. Okay, so now that you can set it's all match. Okay, so that's good. Now, but however, you also have to be careful is that this one they only match the letters. It sometimes the symbol, for example, you see, so this symbol here is small capital, but whereas in the other set the symbol is actually capitalized. So we need to unify that as well, or else then later on you will have problem dealing with the downstream, because when you do the classification, it recognizes the letters as well as the capitalized. So it got to be unique. So I'm just going to okay basically match all these symbols, okay, so that the two data set will be the same. All right, so this is from the CCLE dataset, and then this is from the ICGC. I'm just going to copy this name here and to replace here. So now you should have the same denominator. Okay, so again the able just now. Okay, okay, so now you have two dataset that are so-called clean up. Okay, the next stage what we are going to do is we are going to put it into the Omic to use the machine learning tools to actually classify which cell lines it belongs to which. Okay.